Presentation 1, North Charleston, South Carolina. It's a Mission 9 flight experiment.
Hi, my name is Kayla Capitan. My co-principal investigator, Gabe Voigt, couldn't be here today. We are from Palmetto Scholars Academy, the North Charleston, South Carolina community, and participated in the Mission 9 launch. Our testable question was, how does spaceflight affect the detachment of zinc whiskers on raised access server room floor tile? Zinc whiskers are tiny hair-like protrusions that can form from zinc galvanized or zinc electroplating processes. They are around 2 microns in width and can be several millimeters in length. The cause of whisker growth is unknown, but several mechanisms and behaviors are known. Zinc can form from galvanization or electroplating, often found on the undersides of raised access server room floor tiles, and zinc whiskers can be disturbed by maintenance, and intense vibrations can cause these whiskers to become airborne. Electronic failures can ensue from these conductive airborne whiskers bridging electronic components. Noted electronic failures include apnea monitors, detectors at nuclear power stations, mass memory storage devices, computer servers, components in missiles, bus rails, chassis, and frame rails, and floor tiles in server rooms. Our hypothesis was if a zinc whiskered floor tile undergoes the rigors of spaceflight, then a significant number of zinc whiskers would detach from the sample. Our experimental sample was donated to us from NASA Goddard Space Flight Center, and it is a zinc whiskered raised access server room floor tile, 1 centimeter by 2.5 centimeters big. This experiment provides a unique perspective on zinc whiskers that focuses on the detachment of zinc whiskers in spaceflight. For pre-flight sample analysis, we used a Celestron digital microscope imager at 4 times zoom, angling light from the side of the sample in order to best see whiskers. We used systematic photography in order to understand the sample's geography and to identify the whiskers on the sample. This is an overview image of all of those microscopic images that we took. And this is a table showing the images that we took and the number of whiskers found on each image. And here's for columns 6 through 10. And the last columns, overall, we were able to identify 132 zinc whiskers on this 1 by 2.5 centimeter big tile sample. This is to show you what whiskers would look like versus a fiber on the sample. The top image shows whiskers that are the straight pieces of metal with a light glinting off of it, and the bottom image shows a stray fiber on the sample. For pre-flight sample prep, we used the zinc whiskered floor tile sample, the polyethylene foam, double-sided carbon tape, and the type 1 fluid mixing enclosure. In order to load the FME, we covered the interior of the FME with carbon tape, inserted the tile with forceps, plugged the ends with polyethylene foam, and finished with the NanoRex procedure for the FMEs. For post-flight sample analysis, we used a heated knife in order to cut the FME and avoid vibrations to the sample. We peeled back the FME and removed the tile, used the microscope imager in order to analyze the carbon tape, and angled light from the side of the sample in order to best see the whiskers, using good paper alignment to systematically photograph and analyze the tape. Discoveries. So fragmentation of the whiskers may have occurred due to the stresses of spaceflight. Whiskers of shorter length were found near the sample placement in the middle of the FME, and whiskers of greater length were found near the ends of the FME. Air pockets, creases, and carbon fiber increased difficulty in lighting and analysis. Air bubbles with high relief in the FME may have captured increased number of whiskers. This experiment had limitations. Due to the nature of fragmentation of the whiskers in the middle of the FME, we were unable to determine a count of whiskers. And in addition, lighting was difficult to sustain with the rugged terrain of the carbon tape. For future analysis, using a scanning electron microscope to take up-close images of the zinc whiskers and disseminating our results to the scientists at NASA Goddard. I had the opportunity to speak to the commander of the ISS at the time, Shane Kimbrough, and asked him about the procedures for handling the SSEP experiments. He said congratulations, and that the first steps for the astronauts were to follow the procedures indicated by our proposals. I currently attend the University of Alabama in Huntsville and was invited to present at the Wernher von Braun Memorial Symposium and UAH Research Horizons Week. And in addition, the University of Alabama Systems Honors Research Conference, where I won first place in an engineering podium session. These are my references. And I would like to thank the Student Spaceflight Experiments Program, South Carolina Space Grant Consortium, Palmetto Scholars Academy and Tim Gott, Trident Amateur Radio Club and Tom Glab, Philip and Emily Reed of SPAWAR, Center for the Advancement of Science in Space, NanoRacks, NASA Goddard spaceflight scientists Jay Brousset, Ludmila Panashenko, and Henning Leidecker, Kelly Voigt, David Cook, Matt Turner, and PJ Benfield.
Thank you. Do we have any questions for this team?
My name is Griffith, and I'm from Stamford, Connecticut. So you said in your experiment you had limitations with the tape because it was really rugged and you couldn't see as many of the whiskers, so you couldn't really count them, right? So what would you do to help counter that if you were to repeat the experiment again?
So assuming that you had to use an FME, when we covered the interior of the FME with the tape and fold it back, that creates all of these folds. So, but carbon tape is what the scientists at Goddard used for their experiments. So in the future, I would look at different methods for analysis for whiskers in order to better compensate for that issue.